Okay, on the STAR packet, I'm going to go over a few questions a student missed. First is 34. So you are looking for the domain. The domain is your x values. So you take the point and you go straight down to your x. So, and remember it goes from least to greatest. So it goes from -2 to 3. So -2 to 3. And the only one that has those two numbers is D. So all real numbers greater than -2 and less than 3 are equal to. So both of them are solid, so they're going to both have equal. That is 34, so that's D. Then the next one that was missed is one is 43 and let's see, 37 and 38. So 37. What graph best represents a quadratic function that has no real zeros? So your solutions, which is your zeros, so your solution, your x-intercept, and your zeros are all the same question. So this one has two solutions, and B and D have only one solution. So A represents the one that has no solution because it doesn't cross the x-axis. 38. So on a quadratic equation, you have a max or a min. So, and that's talking about your vertex. So your vertex would be at -1 and -4. So it's at your lowest point. So because you're at your lowest point, this is known as your minimum. And where are you at? You're at -4. So, graph the quadratic equation. Let's see, complete the statement. So right there would be a minimum, and right there would be -4, not at 3. So it's not the y-intercept, it's wanting to know the y value of the vertex. And why do you need to know that? Well, one, your range would be y is greater than equal to the y value of your vertex. Also, at your vertex, you're going to have matching. So if you're looking at the table and you had the equation, these two values both would have a -3 as their y values. And then here and here, your y value would be 0. And of course, these would be your solutions. That's 38. Next that was missed was, wait for it, I think 43. And if you have one that has 4 problems, then I miscounted 33, so we're kind of off by 1. So 43 would be your 44. Okay. So this one can be done 2 different ways. First off, to find the solution, you're solving for x. So opposite of multiplying times 5 is dividing. So you have x plus 3 squared equals, and 75 divided by 5 is 15. And then the opposite of squaring something is the square root. And so you take the square root of both sides. So when you do the opposite, it ends up coming out of the radical. So it's x plus 3 equals the square root of 15. And notice when you take the square root, you have to consider the positive and the negative. And then the opposite of adding is subtracting. So x equals -3 plus or minus the square root of 15. And give me a second, I'm going to show you what that looks like in the calculator. So if you want to put this in y equals, you have to move the 75 to the other side. And hold on, let me put this in y1. 5, open parentheses, x plus 3, close it, squared. And then the opposite of positive 75 is negative. So you have to put minus 75. If you put a negative, it's going to multiply. So you don't want to multiply. So you can go to table set and you want to change this independent to ask because you have 4 possible answers and they are not whole numbers. So we're going to change the independent to ask. Independent is your x, dependent is your y. X is your input and y is your output. So go to second table and notice it's blank. So she can put her answer. So your solutions are the x-intercepts. It's where it crosses the x-axis. So that means that it's when y equals 0. So negative 3 over 5, so divided by 5. And you can't do plus and minus at the same time, so plus the square root of 15. So notice I put the answer as it's written, and when you can do the plus and the negative separately. And you should get a 0, and we don't. But we got D as our answer. So I'm going to put in negative 3. I'm going to do plus first, the square root of 15. And notice I get a 0. And so negative 3 minus the square root of 15. And you get a 0. So it will change it to a decimal for you. And again, your solutions is the x-intercept, and that's when y equals 0. So that's how you know that you have your answer correct. So if all else fails, as long as you can solve for 0, you can put it in y equals and find your answer. Okay, number 44, looks like she got correct. And I've got the last one, which is 50 or 51, and then 47, which is the same as 46. So this one, because these are all exponential, you can do 2 things. You can put this in stat, and then when you go to calculate, you're going to use 0, the exponential function. Or you can just look at 1. So anything raised to the 1 power equals itself. So, for instance, 5 to the 1 power equals 5. So 2/3 to the 1 power is going to equal 2/3. So when x equals 1, y equals 48. So you can put these all in y equals and then see which one produces this table. But simply is 2/3, which is 2/3 is less than 1. If you multiply a number less than 1, you're going to get a smaller number. So 32 times 2/3 is not going to equal 48. That's impossible. It's going to be smaller. 48 times anything other than 1 is not going to equal 48. So that one doesn't work either. And so, and again, D, 48 times 3/2, which is more than 1, it's going to increase 48. So you're not going to get that. So at the minimum, students should put it in y equals and see if they're just going to guess without any thought and see if it works. So raised to the x. And let me take us out of auto or ask. I'm going to put us back in auto. And we're going to start at 1 because our first x value is 1. So that's table start. And at 1, we have 72, not 48. But C, so 32 times 3/2 is going to give you 48. So change this to 32. Go to our table, and that table shows up. So your answer is C. And last is 50 or 51. Depends on which version you have. So first off, the function is increasing. So if you read a function from left to right, the top two are increasing. The bottom two are decreasing. And then it says y-intercept at 2. This one has a y-intercept at 1. This one has a y-intercept at 2. So your answer is C. Thank you.